Hello students, myself Gzal Preet Arneja, Associate Professor Mechanical Engineering Department, today going to interact with you through lecture on control chart for variables. First of all, the contents which I am going to cover in my lectures are: first is variability, second chance cause of variation, third assignable cause of variation, fourth is definition of control chart, fifth types of control charts, then sixth control chart for variables, seventh objectives, eighth relationship between x bar dash, sigma dash and x double bar, ninth is factors in designing of control chart study, 10th calculations in control chart, 11th control chart patterns, and last revision in control limits. So first we are going to start with definition of variability. Why we are going to use the concept of control chart? It is because of the fact that control chart is a statistical device to control the repetitive processes, and repetitive processes we come across in all the manufacturing processes where continuous production or mass production going on, and in such repetitive processes we have the concept of variability, because in nature no two things are made similar. There is difference between the things, so no two things in the manufacturing arena is also not similar. The variations occur because of three factors basically. The first is man, second machine, third is material. Now we are going to study these three factors one by one. First is man, how the man affects the variations in the mass production. Basically the production, there is the difference in various persons, different various workman skills, because their experience is different, because their inherent capabilities are different, because their skills are different. So that is why one person manufacturing a product on same machine will produce different from the second person. So second example we are going to take is, second factor we are going to take the concept of variation is machine. Now on same machine a product produced on different times will be having variations. This may be because of poor quality of maintenance, it may be because of different persons working on the same machine, it may be because of different timings on which the parts are being produced. The third is how the material factor plays the role in variation. We may have the material coming from different vendors, different suppliers. One material may be harder than the other, one material may have different surface finish. So accordingly the material factor also plays a role in variation in the production output quality. So because of these three factors we have the variations which are coming across our production system. So the variations can be broadly classified under two types. One is chance cause of variation, second is assignable causes of variation. Now what is chance cause of variation? Chance cause of variation is if we have the production system which, in which only inherent variations are present, in which only intrinsic qualities of variations are present. We leave the process as such because we do not hunt for the causes, because these variations are only because of by chance. So we have the normal capability, normal distribution curve if we have only chance causes of variation present in our system, and it may be because of different production processes. Supposing we are doing the turning operation, it may be performed on lathe, it may be performed on turret lathe, it may be performed on NC lathe, it may be performed on CNC lathe. So each will be having some internal inherent process variations. So process capability curve or the normal distribution curve of each process will be different. Like normal lathe machine will be having wider spread of variation compared to the spread of variation of normal distribution curve of CNC machine. So, if only chance causes of variation are present, it means that process is under control. We leave the process as such, we do not hunt for the causes, and we say that the process is under statistical control. Second is assignable causes of variation. Assignable causes of variation, the factors we have already discussed is the man, machine, material. Fourth one is the variation in each of the above factor over time. Then last one is the variation in relationship of these factors in combination. Then we have the definition of control chart. Control chart may be defined as the graphical representation of collected information. Now, this information may pertain to measurable quality characteristics or judged quality characteristic. It detects the variation in processing and warns if there is any departure from the specified tolerance limits. So, what the control chart does is it specifies the state of statistical control. Second is a device for attaining statistical control. And third one is a device to judge whether statistical control has been attained. So, we are going to discuss each of these characteristics. First is it specifies the state of statistical control. With the help of control chart, we define the limits, upper control limit and lower control limits, within which we have to identify whether our process is under control or not. Second is a device for attaining the statistical control. If any point goes outside these control limits, it specifies that the some assignable cause of variation has occurred in our system and we have to hunt for the particular cause and we have to rectify it and bring the manufacturing system under statistical control. So, it becomes a tool for attaining that particular statistical control. And third one is a device to judge whether statistical control has been attained, because over a long period of time, if all the points remain under control, all the values of the manufacturing output are under control within statistical control limits, we finally conclude that statistical control has been attained. So, control limits are so placed to disclose the presence or absence of assignable causes of variation, because statistical control limits, the upper control limit and lower control limits are so placed so as to judge whether assignable chance causes of variations are present or not. So, they are placed at plus 3 sigma and minus 3 sigma, because within this particular range of plus 3 sigma and minus 3 sigma, we have 99.7% components lying within these particular limits. It means that only 3 items out of 1000 will be out of these limits, which is very marginal figure. So, we put the upper control limit and lower control limit at plus 3 sigma and minus 3 sigma. So, it means that most of the almost all the manufacturing products must lie between this particular range, and if any quality characteristic goes outside these limits, it indicates the presence of assignable cause of variation. So, these control limits are so placed so as to identify the presence or absence of assignable causes of variation. So, in the long run it reduces the spoilage of work, it reduces the rework, and hence it reduces the production loss. Then control charts tells us when to leave the process alone and when to hunt for the causes. If over a long period of time all the manufactured items quality characteristics are within limits, within control, we do not hunt for any cause, because only chance cause of variation are present and we leave the process as such, and there is no need to hunt for the causes. Then third one is control chart helps us to find out the natural capability of the process, because earlier I have told you that there is the natural capability of each process. I have taken the example of the turning operation, it can be performed by number of machines, like CNC machine which will be having very less variation, will be having lesser spread of frequency distribution, and a normal lathe machine will be having wider spread of frequency distribution, indicates that this is having uh, wider variations present in the system. So, the natural capability of the process is determined with the help of control charts. Then control charts helps us to provide the better decisions on engineering tolerances, because we can determine the natural capability of the process and we can determine which product can be manufactured on that particular machine which we are using. So, it helps us to take better decisions on engineering tolerances. Then control chart provides better comparison between alternate designs, because we may be come across number of designs of the same manufactured products, and means with the help of control chart we can determine the natural capability of the process, and accordingly we can determine, we can design the tolerances, we can design the upper tolerance limit and lower tolerance limit, and in turn we can design the product in a better way. Then next one is the types of control charts. Depending upon the quality characteristics we are dealing with, we can define the control charts into three types. First one is the control chart for measurable quality characteristic. Second one is the control chart for fraction defective. And third one is the control chart for number of defects per unit. Now, in our lecture we are going to cover the first type of control chart, that is control chart for measurable quality characteristic. Basically control chart for measurable quality characteristic is control chart for variables. Under this we have X bar R chart, or we have X bar sigma charts. Second one is the control chart for fraction defective. Under this we have P chart and NP chart. Third one is the control chart for number of defects per unit. In this we come across C chart and U chart. Now, in our lecture we will concentrate on the control chart for variables, that is the first type for measurable quality characteristic. Variable is the term, means measurable quality characteristic which can be measured and put into some numeral value. Example is the diameter, the thickness, width, surface finish, hardness, etc. So, the quality characteristic which can be measured gives us control chart for variables, and these are divided into two main charts, X bar R chart and X bar and sigma charts. Now we are going to study the objectives of using the control chart for variables. The first objective is it is used in combination for controlling process. X bar and R chart are used simultaneously. Similarly, X bar and sigma chart are used simultaneously. Why these X bar and R chart are used simultaneously and why X bar sigma chart are used simultaneously? Because X bar chart is the control chart for average. It shows the variation of average of the process, and R chart shows the variation of spread of process. So R chart shows us the consistency of the process. And X bar chart shows the average, where the average of the process lies. So we take an example why these charts are used simultaneously and not separately, because X bar chart, we take an example like we have A batsman and B batsman. If A batsman scores 50, 50 and 50 score, and B batsman scores 100, 0 and 50 score. The average of A batsman is 50 and average of B batsman is also 50. If we look at the average only, we will come to conclusion that both the batsmen have same performance. But if we look at the range of A batsman, range of A batsman is 0 and range of B batsman is maximum value minus minimum value is 100. So we come to the conclusion that batsman A is more consistent compared to batsman B. So had we used the X bar chart only, we may not come to the conclusion that A batsman is better compared to B batsman. So this is the reason why X bar R chart and X bar sigma chart are used in combination. Next objective of control chart is control chart are used to determine whether a given process can meet the existing specifications without a fundamental change in the production process. So as I told you earlier that each process has its natural variation, natural capability, and we can determine the range within which the manufacturing process can produce the products. Accordingly, we can take the decision that a particular product can be manufactured on this particular machine or a production process or not. So control chart helps us to take that particular decision. Third objective is to secure the information to be used in establishing or changing production procedures. So if we have the manufacturing process which is not capable enough to produce the component within upper tolerance limit and lower tolerance limit, we may have the options like first to look for whether assignable causes of variation are present or not. If no assignable cause of variation is present, we will leave the process as such, and we have the first option to segregate the bad from the good products, to segregate, and then those good products will be dispatched at the customer end. Second option is we may go for a better production process which gives us lesser variations or lesser spread of variations. So this is the diagram. which shows the production process having lesser spread of variation. So, this type of information is provided by control charts. Then fourth objective is to secure the information when it is necessary to widen the tolerances. If over a period of time we have the production process which is producing the products within particular range and upper tolerance limit minus lower tolerance limit is much greater than the difference of upper control limit and lower control limit, then the review of the situation may suggest that the tolerance limits are unnecessarily widened and there is no need to have such wider tolerances because of the functional importance, and we may tighten the tolerances. So, this type of information may be secured with the help of control charts. Then fifth objective of the control chart is to secure the information to be used in establishing or changing inspection process. So, if we come across over the period of time that assignable causes of variation are because of the faulty inspection process, then we have to look, we have to hunt for the cause and we have to improve our inspection system. So, inspection system may be faulty and control chart study may reveal this particular fact. Then sixth objective of control chart is to provide a basis for current decisions on acceptance or rejection of manufactured or purchased product. So, the control chart will definitely help us in taking these particular decisions of acceptance of rejection. We have the purchase section and incoming inspection section as well. So, in the incoming inspection, the material supplied by the vendors is assembled and incoming inspection is done over there, and control chart over a period of time will help us in providing the information to accept or reject if the sample procured from that particular material supplied by the vendor gives us the information that the average lies above or below the upper control limit or lower control limit, definitely we will take the decision of rejection that particular, and if the samples average lies within that particular control limits, we are going to accept the incoming lot. Then the seventh objective is to provide a basis for current decisions during production or when to hunt for the causes of variation and take the action so as to rectify them and to leave the process alone when there is no chance causes of variation. So, control chart helps us to determine whether assignable causes of variation are present or not. So, if there are presence of assignable causes of variation, definitely we will be looking for cause, and if there is no assignable cause of variation, we will leave the process as such and we will not hunt for the causes, and we will save the energy and time and efforts to hunt for the cause which is basically not there because no assignable cause of variation is present. So, it helps us in saving the efforts, and in result it increases the efficiency of our system. Then we are going to cover the relationship between x bar dash, sigma dash and x bar. First of all, what is x bar? X bar is the sample average or subgroup average. X double bar is average of averages, x bar dash or mu is average of universe. Sigma x bar is standard deviation of sampling average. Sigma dash is standard deviation of universe. Now, how we get the x bar values and x double bar values? Basically, we always prefer to plot the frequency distribution by average values and not by individual values. Why we prefer the average values over the individual values? Because average values are more correct compared to individual values, and there may be variations in the man, material and machines, because of which we come across a faulty sample. So, if we plot or use that particular value, individual value of the faulty measurement, it may give us the wrong results. So, that is why average values are always preferred over individual values. So, x bar is basically the average of the sample or the subgroup. X double bar is the average of averages. We have 5 sample size and we have 6 samples to be taken from the lot or the population. The values of first sample and first item is supposing 10, then 11, then 12, then 10, then 11. So, x bar is the average of the first sample, means 10 plus 11 plus 12 plus 10 plus 11 divided by 5. Similarly, we have x 21, x 22, x 23, x 24 and x 25, and x bar is x I j, j is equal to 1 to n divided by small n. So, in this way we determine the x1 bar, x2 bar, x3 bar and x6 bar. Now, what is x double bar? X double bar is sigma x bar divided by capital N, whereas small n is the sample size and capital N is number of samples or subgroups. Then we have range R. R is the difference between maximum value and minimum value. Now, range of first sample is maximum value, that is 12, minus minimum value, that is 10. So, range of first sample will be 2. So, range is difference of